Okay, hi folks, this is the second video clip that I'm doing on this particular problem that was given yesterday. And the first segment I made it using sketches, but I was not very happy with what happened at the end, where I had to, change the scale factor based on trial and error to a value of 7 so that it would give me the graph that I was expecting. Here, in the second segment, I was supposed to do this thing with formulas. Formula meaning writing the script, the C script, so that I don't have to worry about these sketches. And the complication is not going to arise here. But I want to spend a few minutes on showing you why is it that initially, when I thought a scale of 180 was going to work, it did not. Okay? All right, so let me do the following. Let me close this and close that and rewind. Okay. Now, if you go back, double click on this law, these two laws, law 5. Now, in your case, it would have been law 1 because I did several changes, so it turned out to be law 5. I'm going to double click on this. Oh, sorry. Let's go ahead, double click on law. There. Okay. Now remember, what we did was to draw two sketches. The horizontal sketch was 0 to 1. No units, basically. And the vertical sketch is also 0 to 1. Also, in principle, by saying it's going from 0 to 1, I've non-dimensionalized it. But there is this box here, see, it says heterogeneous laws. If you click on it, it says that the applied units, the thing that I want actually is degrees, not non-dimensional. And if that is the case, 0 to 1, if you wanted to convert it to degrees, the factor is going to be 180. And then say OK. And double click on law 6. Same thing. Check the box. Applied units is degrees. And then 180. Then we say OK. Remember, this thing did not work before. Let's go ahead and try to see if it works now. I'm going to switch to DMU kinematics, simulation with laws, activate sensor, run it for 5 seconds. See, no problem. It is working now. And in fact, if I graph it, I get exactly what I expect. So the problem was that I was using the correct scale, except that I forgot to say that the units are heterogeneous. In other words, you have to select the units that are appropriate. Now, the rest of this tutorial is going to be, the rest of this video clip is going to be creating laws. So first of all, I'm going to, these sketches, I can delete it or I can leave it there. I don't need it. Okay, the only thing is that these commands, these laws that I have here, actually, I'm going to delete these, delete, and this one should not be linked to these laws, so I'm going to delete them, and delete. Obviously, if I double click on my Revolute and make it angle driven, I get one command, double click on this, angle driven, and for a second, cancel that, and let's bring everything back to where it was. This is what's causing the problem. Let me delete, update the assembly. It didn't go to back in doing these deletes and things like that. It didn't go back to where it was supposed to. So I'm going to go there and I'm going to make sure that these are all at the place where they're supposed to be, and they're not, as you can see here. So see this? It's not starting where it's supposed to be. So let me see for a second. Okay, let me do that manually and then I go and update it later. So coincidence between this plane and that plane, and update. Okay, now let's go back to digital mockup, DMU kinematics. Okay, very good. So we create our command, double click on this, angle driven, double click on that, angle driven. This seems to be okay. So, alright. It looks like these are still not where they're supposed to be. I have a feeling that let's try to do this one. This is between the rod and the disc. Okay. We did this. And this one is between the disc. Okay. Good. Good. Alright. So this is fine. And this is fine. Excellent. Now, we're going to write formulas. Okay, so remember, this first one was, let me see for a second. Okay, I should have given these, Revolut 2 is rod. Okay, so Revolut 2 is rod and disc, and Revolut 1 is between disc and the base. So just keep that in mind when we do this later. Alright, so we have to go write formulas or C script. So how do we do that? We go to start, make digital mockup on, or no, we go to start, knowledge advisor, knowledge advisor, look for this icon which is, it says if X then Y. So these are rules. So the first one, I'm going to do that for the rod. Okay, for the rod. Can we say okay? All right. So the first one is going to go for the rod. Okay, so let's write down. And what do we got here? If time is less than 2 seconds. Okay. For my mechanism, this is all I want. And command 1 is for Revolut 2, which is the rod. That's correct. So command 1, this is correct. Yeah, this is for Revolut 2, which is actually the rod. Okay, very good. So this is equal to, let me see now, 90 degrees divided by 1 second times time, degrees, dg. Okay, times time, there's a time. Okay, else if time, what is the time? Time is less than 4 seconds, then command 1, yes, equal to, now remember we're dealing with a rod. The first 2 seconds it goes to 180 degree location, so, and then at that point it goes backwards, so 180 degrees minus exactly what we had there, 90 DEG divided by 1 second times parentheses times, don't forget to subtract 2 seconds from it, and finally else, so this is going to take you to location 0 degrees after 4 seconds, else, where is the command. This is equal to. It's gonna the last second is gonna go at double the RPM that you see here. So it's gonna be 180 degrees divided by 1 second times parentheses time minus 4 seconds. Now hopefully I didn't make any mistakes here. Remember, command 1 was for the rod. Okay, that's fine. No mistakes. Another one. Now we're going to do the disk. Let me change the name here. Disk. Okay, so if time, where's the time? If time is less than 2 seconds, then command 2 is equal to, again, 90 degrees divided by 1 second times time. Else, well, the next 2 seconds is going to stay at 180 degree location. Else, if time is less than 4 seconds, then this is equal to 180 degrees. It's going to sit there. And finally, else, the last second is going to go at double the speed. Else, command 2 is equal to 180 degrees plus 180 degrees divided by 1 second times time. Don't forget the parentheses, times time, there's the time, minus 4 seconds. Okay, I hope I didn't make a mistake here. Everything looks alright. Now, let me see now, what are these things tied to? So if you double click on this, you can actually select, this is the rod, very good. Yep. And okay, and if you double click on this, it's going to take the other one. Yep, and this is the disk. Okay, and close it and do simulation with laws. We don't have to worry about these scaling and things like that because it's already taken into consideration. Simulation with laws, activate sensor. All the stuff that we want is already activated. 5-second period. We go there. Hopefully no mistake. Well, let's graph and see what we get. Yeah, this is exactly what we had before. This one is for the disc, and this one is for the rod. Okay, so the choice is yours which one you want to do. So, I'm going to stop here, and good luck on your test.